Hello. It's great to be back. I've been doing FITC now for about 3 or 4 years. This is about my 12th talk I'm giving for FITC. It's a great conference. Sean and all the volunteers do a fantastic job putting this together. It's always a joy to come out. I love Toronto. Toronto's great. It's one of the only towns that I find kind of on the East Coast in the Americas that has root beer. In the southeast part of the U.S., nobody sells root beer. I love root beer. It's so good. We can have root beer and chat when this is over. So you can find me online at Bermon Painter. Bermon doesn't exist anywhere else. So it's great for SEO for me because you just look up Bermon and the first 5 or 10 pages of Google. So super easy. So I'm there on Gtalk and Skype and Twitter and whatever else. Super easy to find. I also had the pleasure of working with Gina Bolton and Mike Parenteau on the SAS redesign. Got to design the logo for SAS, so it's awesome to see that everywhere. And a lot of fun. We did a website. If by chance you like open source and you like writing, we're looking for folks that would want to help out on some of the documentation, kind of unstuck that a bit. So let me know if you're interested and we can talk about it. And then in Charlotte, I organized a handful of community events, one for front-end developers, for user experience designers, and a conference still at FITC in Charlotte, North Carolina, coming up in September. We don't allow devices at all, so it's kind of nice to actually talk to people face to face. And then I work with Cardinal. So a lot of the experiences I'm going to share with you today, and some of the examples come from my experience working as a consultant. We typically consult with a lot of Fortune 50, Fortune 500 companies, and a lot of enterprising things going on. So I'll share a sad story to start out because why not? So we're going to talk about title libraries or style guides, whatever you want to call them. And then we'll focus on kind of an enterprise case study and then talk about some of the nitty-gritty on how you can utilize a pattern library to rapid prototype out ideas or solutions. And we'll do some Q&A. So the tools that we're using that we'll talk about later on in the presentation, I'm kind of a Ruby guy, so most of the stuff that I do is backed in Ruby. So we'll be talking about middleman a bit. We'll show an example of kind of how a pattern library could be set up in middleman. I use Sass for kind of the CSS, use Swim for HTML, and just typical JavaScript jQuery stuff for JavaScript things. Okay, so one of the biggest challenges that I think we face as we're working with companies, large teams that are typically 60 to 150 developers and then some designers somewhere, UX folks another place, is that the challenge that they face, even on a small scale to a large scale, is creating a consistent experience, creating a look and feel that's consistent for the developers, creating code that is reusable, right? So that a year from now, your future self can go back in time and go, oh, I know kind of why I wrote this, instead of, oh, did I really write this? I don't remember at all. What was I thinking? This is horrible. So that's kind of the goal, to overcome some of those challenges. Now, the sad story, right? The sad story. So I spent, the last year and a half consulting with a large company, right? They have about 60 or so developers working on their team, so it's not super tiny. They were working in one gargantuous monolithic application that was built on .NET. So there were roughly 5 developer teams kind of shoved within this larger gargantuous huge application on the .NET. Anybody write .NET? Nobody. I'm in good company. Well, there are a few folks. Don't be shy. There's nothing to be shy. It's a pretty good framework. They write .NET. They're using an MVC framework and using web forms, which is like the older version. They have no designers on their team, and they have no front-end developers on their team. How? I don't really know how or why. So they have all of these back-end developers writing and designing everything and writing the front-end code. And they've been doing this for a couple of years on rewriting some software. And in comes Bermon, doing design and front-end stuff for a company that hasn't done any of that for about 2 years. So it was a little bit different. Right? Let's just say that the designs were, and the front-end code was kind of cringeworthy. It wasn't the best I've ever seen. It might have been the worst I'd ever seen. It wasn't good. Now, the challenge that they have in an organization, or had as an organization, is they have multiple groups of developers working within the same framework. The front end wasn't the best. Here's an example of the front end, because it makes me giggle and cringe at the same time. Big application, lots of stuff going on. They're using two frameworks. On the JavaScript side, so using Telerik, and then jQuery UI, or not jQuery UI, Nintendo, which is kind of like jQuery UI, but for enterprise. And so they have two big frameworks, JavaScript frameworks kind of under the hood. And they're loading, I don't know, 60 to 70 static assets, right? CSS, JavaScript files, that's it. And they're complaining because the pages are a little bit slow. So it takes 10, 15 seconds to load a page. So they'd hired a DBA, and they were optimizing the database to death, but it wasn't really speeding up the site at all. And looked under the hood, oh, you have a lot of assets going on. They weren't unifying anything, they were concatenating files, and then looking at their headers, they had gzipping turned off and caching turned off. So typically when you go to a website, right, you cache the static assets locally, so you don't have to reload them every time you go to a page. So they had turned that off. It said, no, we don't want to cache any of our assets on any page ever. So every time somebody's loading a page, it has to download that 2 meg payload over the internal network. So the pages are slow, the network's slow, because you have a large company using this internal application every day, all day long, loading pages left and right, and downloading assets every single time. So it was all slow, not very fun. So that's my front-end story. Don't do that, please. Never ever do that, small or large teams. And then because the developers are trying to do design, let's just say the app wasn't that easy to use for the user. Right? It didn't make a lot of sense going from point A to point B. Now, as developers typically are sometimes, we don't talk to each other very often, especially when we're working on different projects. So they didn't really share what they were doing. Across the different teams, they were reinventing the wheel a lot. And then because of all of that, the culmination of, this is like the perfect storm of how not to do app development. They missed a lot of deadlines. They went over budget by so much. Not by like 10 grand or 100 grand, like $1 million, right? So big company, big budget, they spent a lot of money and didn't get a lot out of it. In the end, they basically went into a silo for 2 years and built this software and didn't really show it to anybody. They just kind of built it. So the CEO of the company, he's off. He's a sales guy. He's going off. He's selling stuff. He comes back 2 years later. He swears a lot. I don't swear. But imagine the very raspy voice CEO coming in, like, what the bleep is this? I don't like this. And so they shipped the wrong thing a lot. Not the best. So enters Bermon, right? 2 years have passed. Bermon comes in as a consultant. And it's not the best environment. It's an awesome team, awesome people, really smart. They're just missing some core competencies to build really good software. So can't change everything, can't go back in time, can't cause them to rewrite the software. So what we started to do, we started to kind of inject this concept or this idea of building a pattern library. So the way I define a pattern library is it's just a collection of documentation that defines interaction patterns, design patterns, the structure, HTML, CSS, JavaScript, and kind of how those patterns should be created. And then in what we were trying to do, because we had a lot of developers that didn't design, really write front-end code, defining how they should be structured, when you should use a pattern, why you should use the pattern. So they had a really good standard set of documentation on how to build their application. So in my brain, that's kind of how I look at pattern libraries. So the reason that we wanted to implement a pattern library for the company, I'm a user experience guy as well, so I manage user experience practice at Cardinal. So our focus is on the customer or the user. We don't want them to hate using the software every day. So We wanted to build these patterns, make sure that they were easy to use, and to utilize those in the overall applications to have a consistent user experience, which they didn't have. For look and feel, kind of all over the place, right? Two different frameworks, some stuff that was custom didn't quite look the same. So we wanted to establish a consistent brand, if you want to call it that, for their applications. And then a consistent language. So you get the business folks in the room, and the designer, and the front-end developer, and the back-end developers in the room, and develop a consistent language around what the patterns are called. And so when you're referring to things in meetings, the team are referring to the same, referring to things and they understand what they're talking about. And then for developers and for designers to come across the board, creating these patterns that are highly usable, right? If I create an accordion, I want it to look and function the same across a mobile device or a tablet or a web browser, anywhere in the application. So I want to use that stuff. And then I want to be able to maintain that information, right? I don't have to write 2 or 3 or 5 different accordions depending on where I'm at in the system. So I want to have this core component that I can use and reuse. So this is how we started working with the team to help them identify what patterns are. And the whole concept that's become more and more popular in the past few years is that we're not really designing pages anymore. We're designing a system, and we can use that system to create those pages. So this is meetup.com. We use it a lot in Charles for a lot of our events. And it's a good example. There's a lot of stuff visually that's kind of going on their pages. Now, if we look at the site, we can take each page and we can break that down into various patterns. So Meetup has a few patterns that kind of bubble up right off the bat. At the very top, right there, we have a horizontal set of links, right? We also have another horizontal set of links here, another set there, and then another set here for the tags. Now, if you're writing the HTML for that, you're probably going to use an ordered list or an ordered list. It's not going to be very different between each one of those horizontal bits of navigation. Now, the content might change a little bit depending on the context, but overall, it's about the same. If we're writing this in code, we slap on a class to differentiate look and feel. There we go. We have kind of a singular pattern, a singular structure, and that's a horizontal nav, and then just a few different variations in how it looks. So that's one version of that. It doesn't like that. So we have horizontal list of links. Not too bad. We have another horizontal list of links with some secondary information, styled a little bit different. Same thing, we have a series of vertical links, and then vertical links down here, if you can see that far. So again, it's going to be the same structural HTML for the most part. It's still an ordered list or an ordered list. You slap on a class, give it a different look and feel, and that's another pattern, right? So we have roughly 6 or 7 different patterns, but have similar HTML under the hood. The only thing that we're really changing is the CSS. See, it'll go like that, something like that. And then that's kind of what we do. That was the exercise, is to take all of these pages and build this library of visual patterns and functionality that existed in the current system, so we could try and consolidate and simplify and make a lot of that so much simpler. So the requirements that we set within the team is what constitutes a component or a module. So the first rule is that we have to be able to mesh it, right? We need to be able to take that component and then put it anywhere on the site without it exploding. 2, we need to combine that module with other modules, right? We want to be able to kind of mix and match and combine things together to create brand new modules. And then 3, who works with Flexbox at all? A few folks, do you love it? I love it. It's nice, right? Dealing with floats is kind of a pain, but it's not going away anytime soon. It's getting closer. Flexbox support has gotten pretty good, but it's still not quite there yet. So we're still dealing with floats a lot. So because we're dealing with floats a lot, any module needs to be clear fixed, meaning that we're preventing for the parent container from collapsing on itself. And it just makes things flow much nicer on the page. 4, responsive is kind of the norm now. Right? It's not brand new. It's not even moderately new. It's been around for a few years now. So any component that we create needs to be flexible. And then 5, and I think this is kind of one of the most important pieces that allows us to build a really flexible prototyping system, is that we have to separate things that define structure and things that define the look and feel. So essentially what that allows us to do is that for every pattern that we create, there's a baseline structure set up so we know that we can put that on any project, any page, and structure is going to lay out correctly. And then the only thing that we have to do is layer on look and feel. Right? So we can use the same pattern in multiple places and layer on a theme or a look and feel so it matches whatever brand or company that we're using these patterns for. And then 6, because we work so much in enterprise, and the reason that we have interpreters here today, is that these components that we create need to be accessible. Not everybody has perfect vision or perfect hearing. I wear glasses myself. It doesn't affect me hardly at all unless I'm driving tonight. Then it's pretty bad. But other than that, I get along pretty well. So each module that we create needs to be accessible by a student, right? And it needs to be accessible to folks that may have colorblindness. So whatever those needs may be. And there we go. So pattern libraries are great. I really enjoy building them. The big drawback, especially if you're starting from scratch, is it's not instantaneous. It takes time to create the patterns, to test the patterns, to document all that information, and then it takes time to educate the developers and educate your bosses. It's not going to happen overnight. So with the client that I was consulting with, it was basically Bermon sitting in a queue. It was a nice queue. It wasn't horrible. It wasn't soul-sucking. But they had a pretty good setup. Creating a pattern library for 6 months and writing custom components in custom JavaScript. And working with the developers and kind of showing them how this would work in .NET. But again, it was still 6 months of somebody's time. Now, the benefit is that we can create the system where we can show the patterns, and then once the pattern is complete, we can switch it out to what's in the application. So it's not like you wait 6 months and then you use it. You can use the patterns as you complete them. So the foundation of the system that we're going to use, and that I'll show off here in a bit, is Middleman. So Middleman is a static site generator built on top of Ruby. It's actually running on top of a Sinatra server. So it's rack enabled if you're familiar with Ruby and kind of how that's set up. If not, it doesn't matter. Middleman doesn't care. It's easy to set up and easy to use. And I love it because I can spit out stuff really easy without having to do a lot of work. We're using Sass and Compass for our CSS. So Sass, if you're not familiar, is a preprocessor. It gives you the power to use things like variables and extra CSS, which feels pretty darn natural, right? I don't know why we can't do that in normal CSS. It's really nice. And then you get more powerful things like creating custom functions and doing mix-ins and using things like extend. And what that allows us to do on the CSS is also create this nice modular CSS setup. So, for example, I don't have to worry about what were the hex codes for all my branch codes. I can stick those in variables and use that throughout my CSS. It's really nice. Even if you only use the most basic things of Sass or less or stylus, there's so many great gains from using something like that. And then we use Suzy for our grid system. So Suzy is an unobtrusive grid system. I love it. I think it's the best because I'm not very math-minded. Doing the math it's not my thing. So what Suzy does, it does the math for me, but it doesn't dictate how I should write my CSS. So however I feel like structuring my CSS with the grid system, I just utilize them to calculate all the math and make it responsive. It's great. So the base of everything is code standards. We develop a library of code standards that just define when you use an H1 or an H2 or an H3. Basic things that a front-end specialist would know, but maybe a designer or a back-end developer might not know, just so the entire team is on the same page. So we document those standards. 2, we develop a system of base elements. Now we're lazy or efficient, depending on how you look at it. We just use a version of normalized CSS kind of break that apart and adjust it based on our needs for each project. So that forms our base. So anything that's a native element that we're styling would live in our base. 3, we have the modules. So the modules is one of the magic happens. This is where the singular components would live. And then within each module, we have 2 sides of that on the CSS. One that's our scaffold or our structure that handles anything that's not tied to look and feel. So margins, paddings, border widths, anything like that would live in our scaffold. And then on the other side of that, we have a CSS for our thing. So this is anything like background colors, border colors, anything that gives it a look and feel, anything that allows us to style the box. So with all that said, let's kind of dig in a bit, and we'll do a demo. And I'll show you the pattern library itself, and then I'll show you the code so you can kind of see what happens. So this is kind of a cleaned up version of what we built. So code standards live here. Again, we're defining simple things like HTML, CSS, JavaScript, the patterns that we use when we're creating a JavaScript module. We're defining things around responsive web design, what constitutes responsive design. We're defining our accessibility guidelines so that we know that when somebody's creating a component or a module, they're complying to whatever we require them to do to create something that's successful. For them, we talk about performance, what you should not do. Use caching, use it, concatenate your files, minimize your stuff. Don't serve 80 files to the client. Things like that. That, again, a front-end specialist would probably know, but some folks may not. So we want to teach, and then we have our base. So our base, we dump in things like our grid system. Now, this grid system was built to be flexible, not necessarily responsive. There wasn't a big responsive requirement for this particular project because it's an internal app and it was meant to only work on desktop. There were lots and lots of forms, so we didn't do a lot of responsive work for them. Now we did kind of a bootstrap-esque grid system for them that was very class-based. I think that's good for developers that don't really write front-end code because you go, hey, we're building this on a 12-column grid system, and then you just choose how many columns you want an element to take up. That's pretty easy for developers to grasp. If I was working with a full front-end team and they were dictating this, I would abstract the grid system behind the scenes using SAS placeholders, so I don't have all of these non-semantic classes in my HTML. So they're kind of behind the scenes where nobody can see it, except for the front-end folks. We define simple things like headings forms. So again, within the pattern library, we're describing or defining what a pattern is or what a module is. In this case, what's a heading? You'd be surprised how many people don't know the difference between an H1 and an H6. It's pretty common. At least in enterprise, it's painfully common. So we define that stuff. We give them some good examples. All the magic, again, all the magic happens in the modules. So for them, we define 30, 35 modules kind of out of the gate. The patterns that they use the most. So this is an example of the alerts that we had. Again, what we're describing, what is an alert? Why I should use it? And then we're defining some usage examples for them so they know that there's a wrapper they need to use, how to handle titles, how to handle the content. And then they're a huge jQuery shop, which is, it's okay. But that's what they wanted to use, so that's what we use. Now, we give them some good examples. So there are 4 types of alerts that they can use. In this case, there's a typical message that we just, hey, here's a thing you should probably know, but it's not too really important. We give them a warning, an error, we give them a success, and then we wrote a custom alert module for them so they can use that if they want. It's just an X that they can click on. So there are a few variations of this. That they get a fully functional visual example of what that is, that they can interact with and see how it's supposed to function. And then they get an example of the HTML. Now, we'll get into this shortly, but we define the HTML here, the structure here, the classes they need to use, and then they convert that into a .NET control. So that they basically create a secondary .NET control that encapsulates the HTML, and they inject the content in, and then they can define the CSS and the JavaScript that this module needs to function within .NET, which it's pretty great, but we have some redundancy there that we'll talk about here in a second. We have an alert with no content, and then we have an inline alert that they could use, say, in a form where they want an inline message to kind of show up. So we do that for all of their patterns, which is pretty useful for them. An example for a button. So this is an example where we combine a couple different patterns. They have a primary button. We set this up to work across a button and a link and an input because they're silly in how they write some of their stuff. .NET is kind of odd sometimes. There's a secondary button, which is grayed out, and then we define their button pattern. So their pattern was primary actionable button on the far right, kind of the secondary action button, gray, also on the far right, and then something destructive, far, far away of anything you want them to click on. So it's on the far left. That would cancel something. And again, we gave them some custom HTML. Let me actually bump that up a bit. There we go. We gave them some more HTML to just show what a button group would look like. So again, we're taking patterns that are defined and creating secondary patterns off of that. We did the same thing with things like checklists. So they wanted something weird like this. So we built it. And then there's a whole bunch of stuff around forms. If anybody ever asks you to create custom selects and custom radio buttons and things that you can't style with just CSS natively, just kick them in the teeth. It is not the funnest thing to do, but they always want it, so we do it for the most part. So we gave them some custom forms so they can have stylized checkboxes and radio buttons. It works. So we do that for them. We show them how to kind of group fields together so they can have like a zip code pattern in the forms. We show them the states. So there's an error state. And this is kind of where it gets nasty because they are so form heavy. And this is the reason that we wouldn't use something like Bootstrap. One, because I kind of hate Bootstrap, but some folks love it, and that's fine. But in this case, they have this need where they have a horizontal form pattern with vertical form patterns, and then like a horizontal combination. So that's what we built for them. So there was a decent sized layout system for forms for them, so they could do those types of combinations, which wasn't the funnest thing to build, but again, they kind of needed it, so we built it for them, and then we give them the example of HTML. So that's how we define all the patterns, and again, we're using Kendo, so there's some Kendo stuff in there. And the magic, I think, happens is when we go in and we want to take all those patterns that we built and actually create pages. So we create something like this. So this is a combination of, I don't know, 10 or 15 patterns that we define for them. So they're very process heavy or very task heavy and very form heavy. Because there are some fairly complex interactions with data in their system, or some not so easy to use workflows from getting from point A to point B, we want to be able to prototype that stuff out pretty quick without having to build a database schema and set up an application. So we went through and built this 7-step process after we defined the patterns. And it probably took a couple hours to build it out, right? We already had the patterns, just copying and pasting HTML over and putting in dummy data and kind of tying it together within middleman. And what that allows us to do as a team is we get something real that, in our case, is enterprise ready. So it's already tested, it's already browser tested, it already has unit tests attached to it. And we can test and see how those patterns work together. And we can also test as users are flowing through a system to see what works, what doesn't work, where people have issues, where we might need to augment some type of secondary data or contextual information about why something is the way it is. And so again, that allows us to move fairly quickly once the patterns are built to build out these really nice quick prototypes that are fully functional. If this is responsive, we could try it on a phone, we could try it on a tablet, we could try it on the desktop. that'd be great, right? We're totally faking the data, but that's not too terribly important yet, because we're not quite sure we've gotten to where we know we're building the right thing. And that's what we want to vet first. So you have those examples who are just running people through. Yeah, there you go. So there are a couple of other prototypes. Now, under the hood, we'll use some of the accessibility stuff so we can zoom a bit. All right, so this is how middleman looks under the hood. There's a gem file, so if you use Node or anything like that, you have npm, that's a package manager, and then like other package managers, there's a package manager, but that's Node. In Ruby, you have a gem file, so gem manages the packages. All of that kind of comes with middleman, so you don't have to do anything with that. Most of everything is set up by default here in your config file. There we go. So the reason that I like middleman is it has so much built in under the hood that I don't have to really do a lot of setup. It has SAS built in, it has ERB built in for templating. I switched that out for Slim because it's a bit more concise. It has live reload built in. Who's never used live reload? Don't be shy if you never have. A few folks. I'm going to blow your mind because it's amazing. So essentially what live reload does for you is it pulls your file. So it's constantly looking to see when you change files. So whenever you change HTML or CSS or JavaScript, it goes, browser, you should refresh now. So it refreshes for you automatically. So essentially what I can do is I can have my browser here, and I can have my code editor here, and I can keep typing and changing things in my code editor. So as I'm changing my HTML and CSS, my browser is continually refreshing, so I can see my changes nonstop, right? So it's good for workflow, so you never have to take your hands off the keyboard to see your changes. Click and refresh a lot. I'll still do that for you. Now, on the CSS side, what live reload will do is it will refresh the browser, it will repaint the page for you without refreshing the browser. And that allows you to do things like maintain state. So if you've gone through this process, you've clicked and the model's shown up, and if you refresh, you have to start over again. So if using live reload, it'll inject the CSS, change look and feel the page, so you can maintain state as you're making those things. So it's great. So all that's built in for you, and then it just runs on a server. So defaults, if you see here, at port 4567. Well, pretty good. So it just runs locally, and you can kind of tinker and poke around. Now, all of the magic happens in your source directory. Now, because this is a static site generator, what it does is it takes the information that you've built in your source directory, and if you tell it you want it to spit out static pages, in this case, you just type middleman build in your console. It'll spit out a build directory with static HTML and static CSS, and you can take those static files and FTP that to the server or push that up to GitHub pages, and you have a nice personal site or a blog. I use this for all my non-CMS based stuff. I think you just CMS if you just write HTML yourself, it's easier. So that's what it'll do. Now, the way we structure this, a lot of this happens in our source directory here in our assets. Now, I like to structure mine and have a folder of fonts, images, JavaScript, and style sheets. In the images, I divide it up with content-based stuff, things that are specific to layout, and then things that are specific to the style guide. So I'm not muddling up my application stuff with stuff that makes my style guide look the way it does. Under the JavaScript, this is probably pretty common. There's a libs directory where we're putting things like Pindo and jQuery and Modernizer and Ignore Selectivizer is pretty much dead. And then we have our modules directory that has all of our modules that we've written for them. So those are there. And then if you're using a build system like Grunt or Gulp, you can concatenate and file those files and insert a single file for the build function. Wrong way. Got too big, too fast. We're using Jasmine for tests. So Jasmine kind of runs there as well. And then for the style sheets, this is how we have things set up here. So we have a base. And again, if you look at this and compare it to normalized, we're just taking the sections or chunks that are in normalized and separating those out in separate CSS partials, which is great. We have helper series. This is like the functions that we can do in SAS or any mix-ins or any utilities, class-based utilities to push and pull stuff. We have the Kendo stuff that you can ignore. We have some setup stuff here, which is just variables, right? So we're defining any global variable that we want to use. Our baseline, sub-baseline. For SUSY grid, we're defining how many columns that need to exist in the grid system, the width and the gutter width and all that good stuff. We're setting consistent variables for the line height for our form elements, the height of the forms themselves, headings and all that great stuff. But you'll notice that everything here is structural, right? There's nothing that's theme-based yet. And then within our theme file, we create a folder for the theme. For example, we call it first cardinal. So here's our cardinal theme. And there we go. We're mimicking the structure that we saw in our modules. So if we look at accordion, with the exception of a poorly written mix-in, there's nothing that's based off the theme, right? Everything is border widths and margins and paddings and things that are defining the structure. Now, if I go to the theme version of that, again, it's just background colors and font colors and things like that that are specific to the cardinal theme. So what that allows us to do is it allows us to silo off the CSS that gives us structure and the CSS that gives us look and feel. So I could technically spin this up and gray box out a whole bunch of stuff without any real theme, just so I could test functionality and user flows. And that's roughly the way it's set up. Right? There's not too much complexity built in there. Now again, this is fairly manual. I kind of like building it that way. So there we go. There's an example of what's in there. It's all on GitHub. So if you go to GitHub and look for Cardinal Solutions, this is just called pattern library. Super inventive on editing things. But that's what it is. Now, that's all great and good. But some of the challenges that I think that exist within these type of pattern libraries is that it's only half efficient. So there are two types. The most common and the one that most people are using right now are these pattern libraries that are static, right? You have static HTML that exists either in middleman or something like that you're building the VBs. This is like the first one that I recall ever seeing. I thought it was fantastic. I still think it's fantastic because they defined so much and gave so much away on how they're building things for such a large company. It was just really great to dig into. And you have things like Salesforce. I love this. It's nice to design. It's interactive. It looks great. You have things like pairs that again they're defining how something looks visually, the HTML and the CSS. And then you have something like our Pattern Lab from Brad Frost, which is just fantastic. It's a great system, a great way of thinking about how we're building products. The second option to that are the generators that exist. Some of them are great. You know, like Spellbox is pretty popular. You have PSS that GitHub uses extensively. My personal favorite is Hologram. It's built on Ruby. And you're storing a lot of your structural commentary or documentation in your CSS. The generators will parse the CSS and spit out the appropriate exceptions for you. It's a bit more efficient than doing it from scratch. I just like full control. But don't be afraid to use one of the built-in systems. Now, the challenge with any one of those options is that you're duplicating HTML. So I have my HTML for the static version, like middleman. It's stuck in middleman. There's not a good way to get those patterns out. And if I'm using a generator, my structure, my HTML is stuck in the CSS comments. I mean, it's not the best. And what that causes is an increase in maintenance. So if I change the pattern in one location, I then have to change it in every other location that it exists. So not the best, but again, it's good for right now. So I think the best idea, the best thing that I've seen, and kind of where I see things are going, is having this pattern API. We talked, I think, lightly about this in the web component panel earlier, and that's kind of where web components is trying to drive this, but it's not quite there yet. So the idea behind creating kind of a pattern API or a module API is that I can take my preprocessed code or non-preprocessed code, depending on how you want to treat stuff. So in my case, I'm using Slim for HTML, SAS for CSS, I'm using like copy script for JavaScript, and along with that, I have my unit test, my functional test. I compile those to HTML, CSS, and JavaScript, and then I can take that component that's kind of this self-encapsulated group of HTML, CSS, and JavaScript, and I can use that in my pattern library. So I have a separate location for my modules, and I can use those in the pattern library. Or I can use those, I can go to that same service with that API and use that in a product or a service. Or I can use that in local products or local services. Or best case yet, I can use that central API for any product or service that I want to, and I can use that in my style guide. And so what that allows me to do is to have kind of this single source of truth for every single component and their dependencies is stored in one location, and I can use it anywhere else. And that kind of removes the redundancy that exists currently in the static HTML pattern libraries that exist. Now, the only company that I've seen doing this publicly and has been very open about what they're working on is Lonely Planet. They've been doing some great work. They're a Ruby company. Everything's based in Ruby. They have a lot of great examples on GitHub. There's a couple blog posts out there and a video from the conference that talk about their approach. So, if you were to compare the two, that's where I think the biggest differentiator is in that we're trying to reduce the complexity of the things that we're building. And the HTML is kind of a wild card right now. Where if we use a build system or we're using something to generate the pattern libraries for us, or we're trying to create our own, we have redundancy in the HTML. We want to try and remove that. So the goal, I think, and the next step for us that we're serving on with our team is creating a cloud-based API that we can just call, get the components that we need, build those on the back end, and then serve up the build pages to the client. So that's where I kind of think things are going, and that's my thoughts. So that's all I have. I think I might have like 1 minute or two, maybe 3, 2 or 3. Any questions? There's one in the back. I feel your pain. Yeah, I think Ember's a good one, right? Ember's good. Angular's pretty good. A lot of folks do this stuff with React. I think based off conversations today, Ember sounds a bit more stable. Angular is about to do kind of a 2.0 release, so I'm consulting with a bank now, and they're an Angular shop, and one of their challenges is they know that Angular 2 is coming out soon, and they're going to have to re-architect what they're re-architecting right now. So there's kind of a pause on that one, but I would choose any one of those and just go with it. There's always going to be change ever before in the web, so just pick one, learn it well, read the docs, and see how it works. You're welcome. I have 0 minutes. We can chat after. I'll be around until like Tuesday. So thanks, everybody.